Hello, today I would like to talk about sensory attenuation with a virtual robotic arm controlled using facial movements. When we voluntarily generate stimuli, we perceive them weaker than stimuli generated by others. For example, when there is a button that generates a sound, the intensity of the sound changes when I pressed and when someone else pressed. This phenomenon is called sensory attenuation. The sensory attenuation is caused by our own voluntary action. So, if the sensory attenuation occurred, we distinguish whether the stimuli was generated by self or others. Also, by providing consistent stimulation across multiple sensory modalities, we can have an illusion, such as rubber hand illusion. It can be observed over avatars. If avatars follow the user's movements, the user feels as if the avatar was their own body. In other words, the sense of body ownership and the sense of agency are induced. Moreover, a previous study shows that the sense of body ownership over a rubber hand was correlated to the sensory attenuation. Also, sense of body ownership and the sense of agency are observed on the extended body. An example of the extended body is a robotic arm to augment human abilities. By mapping users' action to extended body manipulation, the sense of body ownership and the sense of agency are induced over the extended body. Many studies assessed the sense of body ownership and the sense of agency over the extended body. However, the sensory attenuation on the extended body have insufficiently been explored. In this study, we examine sensory attenuation and body cognition on extended body in a virtual environment. To address this purpose, we set three research questions. The first is the sensory attenuation observed over the extended body? The second is, are there any differences in sensory attenuation between the extended body and the innate body? The last is there a correlation between sensory attenuation and the sense of body ownership on extended body? We explored these research questions through two experiments. To assess the sensory attenuation on extended body, we developed a system. Our system allows participants to control the wearable robotic arm with facial movements. The facial movements were captured by smartphones. Using this system, the participant performed sound comparison task. In experiment 1, we investigated whether sensory attenuation was observed on extended body. We assessed points of subjective equality of auditory stimuli under 4 conditions. The sensory attenuation is induced by self-initiated stimuli, so we set the condition by who controlled the logic arm. Under each condition, the logic arm was controlled by the participants and other persons, a machine, and nobody. This experiment was designed based on the previous study on sensory attenuation. We recruited 39 participants from the crowdsourcing services. This experiment began with a downloading application for the experiment. The participants followed the instruction of the application to adjust minimum audible pressure and perform calibration of face. After that, the participants performed training and then moved to sound comparison task. This is a video in training phase. After reading the instruction, the participant pressed the button with robotic arm controlled by mouse movement 200 times. In test phase, the participant pressed the button with robotic arm. Immediately after pressing the button, the sound was generated, and after a random interval, another sound was produced. The participant answered which sound was louder. The sound pressure of the former sound was 74 decibel, and the latter sound was a range within 71 decibel and 77 decibel. The participant performed sound comparison task 175 times. Using the participant answers, we calculated the PSE. The PSE is a point where an observer perceives that two stimuli are equal. Psychometric function is used to calculate the PSE. We applied the probit regression to the participant answers, and we calculated the mean of the distribution of interest. The mean value was the PSE. If the sensory attenuation occurs, the PSE decreases. The results of experiment 1 shows that the PSE under extended body mass condition was significantly lower than the other conditions. This indicates when the participant controlled the robotic arm with their mouth movements, the sensory attenuation was observed. To explore further, we conducted experiment 2 to investigate differences in sensory attenuation between innate body and extended body. In this experiment, we investigated the extent to which mouth movements were related to sensory attenuation. So we compared the situation that participants voluntarily controlled robotic arm with mouth movements. The participant moved mouth, but robotic arm automatically moved. The participant moved the mouse to press the virtual button. The participant pressed the button on the screen with their hands. And baseline condition. We recruited the 29 participants through crowdsourcing services. The procedure was almost the same as the experiment 1, but at the end of each condition, we asked the sense of agency and sense of body ownership questions to participants. Here is the result of point of subject equality. The PSE of extended body mass condition was lower than control condition and extended body machine mass condition. This indicates the sensory attenuation occurred by voluntarily controlling a robotic arm with their mouth. Also, our analysis found the correlation between sense of body ownership and the PSE under only extended body mass condition. By mapping mouth movements to robotic arm, the sense of body ownership were induced and the increase of sense of body ownership attenuated audio stimuli. And we found the correlation between sense of agency and the PSC under extended body mass condition, virtual button mouse condition, and virtual button and hand conditions. Therefore, the analysis shows that when the participant voluntarily controls the button or a robotic arm, there was a correlation between sense of agency and the PSC. Let's move to the discussion. Our experiments indicated that audio stimuli were attenuated by manipulating robotic arm with voluntary facial movements, showing that sensory attenuation occurred on the extended body. We address each research questions. In terms of research question 1, the experiment 1 and 2 showed sensory attenuation was observed when the robotic arm was manipulated by the participants' voluntary mouth movements. Regarding research question 2, we found similarities and sensory attenuation between the extended body and the innate body, but differences in sense of agency. The sensory attenuation correlated SOBO or overhand was found by a previous study, but the other previous study on the innate body revealed that sensory attenuation did not correlate to sense of agency. So we will further study the correlation between sensory attenuation, sense of body ownership, and sense of agency in the future. In terms of research question 3, our analysis revealed that sense of body ownership negatively correlated to PSE. So when the sense of body ownership increased, the PSE decreased. This implies the possibility that sensory attenuation can be an embodiment measure for an extended body. Conclusion is as follows. Thank you for your listening.